It's Stan Best here at Alpha Micro, and we're going to talk today about the high voltage test rig we did for proof of concept of isolation. We've done some theoretical numbers, but we wanted to actually run it in practice. So the approach we took was this, which is to put a spark gap with a calibrated distance in parallel with the test piece, so we can give it a surge, which is quite testing, and at the same time have a very good idea of what the voltage has gone to. So we've got a couple of setups here, and you can see the development spark gap we've got here, which is a piece of brass. There's let me just turn the HT off before we do this. This gap here, we can crank this in and align and adjust these points so that at 0 on the millimetre scale they're just touching. We then work to a rule of thumb of 3 kV per millimetre, and we can then crank this out to get various voltages. Now this was an early unit where the creepage and clearance were a bit low, and if we set it to 1 millimetre here, let me just do that, switch the power on, operate this. In fact, it's still breaking down across the you see it breaking down across the board. Now we now have another unit here. Let me turn that off before I handle it. If I put this one on, which was designed with true attention to creepage and clearance, I'll just ground it to here, turn the power supply back on, and in fact, if you can get in there, you can now see that at that voltage it's now choosing to jump the spark gap. And in fact, with this one we can take it out to 3 millimetres, which is 10 kilovolts. Got it. There we are. Do it again. And if we get the camera in, we can see the jump still across the points. Now, because this is, the calibration of this is using a rule of thumb for the breakdown of air, we took this out to 7 millimetres. Let's just check that. 7 millimetres, and tried it again. So this is, and if you look now, there's no breakdown across the test piece, but we see a lively spark jumping across the test gap. So that gives us confidence that in the real world this is performing pretty well. Now, the model we've used here is that we assume that at these voltages both the core and the screen will short out together, and the most testing situations obviously if they short together both sides. So the physical model here follows that model, and we've just taken a single piece of wire, strapped up the core and the earth both sides, so both earth and the core are being stressed simultaneously to this voltage. So I think we've been very impressed with the results of this thing, and we just feel that that shows we're there.